I just received breaking news about Tesla's billion-dollar investment in 2 new batteries, and I confess, this will shake up the market. During the aluminum and sodium-ion tests, Chinese and Korean companies have already started paying attention. Tesla's shares have soared 16.7% and are just 10% away from their all-time high. You can imagine the repercussions. While Elon Musk is still keeping the details under wraps, I've already gotten the latest updates on these 2 revolutionary technologies. The historical energy density limitation of aluminum ions has been virtually eliminated with the new formula, and the cost of sodium ions has plummeted much faster than we expected. In today's video, I take a detailed look at the groundbreaking advances in aluminum-sodium batteries at Tesla's labs. And finally, we'll discuss how this could enable the Model 2 to launch for under $25,000 in 2026. If you're not already a subscriber, click subscribe and join our 10,799 subscribers to closely follow every Tesla update, where each new feature can represent a real advantage, both on the road and in life. How is Tesla increasing the energy density of the aluminum battery? We're talking 45% more than the previous prototype. No fire risk, ultra-fast charging from 0 to 100% in just 8 minutes, and a lifespan 3 times longer than lithium, maintaining 89% capacity after an impressive 2.5 million miles. And all this fits into a single aluminum package. But there's still one concern that gives many Americans, especially our Auto Gear Shift subscribers, pause: range. In early versions, aluminum batteries only reached 220 Wh, far below the 250-300 Wh of lithium, offering somewhere around 250-300 miles. Not convincing for those accustomed to long trips in gasoline-powered cars. The good news: the latest leaks from Q3 2025 testing show that energy density has increased by 45%. How did this happen? Tesla optimized the space inside the aluminum-ion battery pack. The secret lies in a 3D honeycomb design for stacking the cells, reducing the thickness of the cells from 50 nanometer to just 10 nanometer, interleaved and overlapping. The space between them dropped to less than 800 nanometer, reducing 84% of the empty volume. The result: 5 times more cells can be stored in the same battery. Another innovation is the application of a 0.5 nanopolymer to the graphene anode. Previously, graphene had a large surface area, but stored ions only in certain areas, wasting the rest. Now, with the coating, the ions are evenly distributed, increasing the cathode's capacity from 65% to 95%, or 1.5 times more stored energy. This brings Tesla's aluminum battery to 320 Wh, a 45% increase without adding weight or size. In a 75 kilowatt pack, that translates to up to 450 miles of range, surpassing the Model Y long range, 330 miles, Ford Mustang Mach-E, 320 miles, and even the Rivian R1T, 410 miles. If you're the type of person who loves long trips, write in the comments aluminum ion 450 miles. This technology could finally put an end to the range anxiety that made so many people doubt aluminum batteries. What about the sodium battery? Just 4 months ago, analysts projected production would cost around $30 per kilowatt, 3 times cheaper than lithium. But now Tesla has managed to reduce the cost even further, reaching just $11 per kilowatt. How? The company replaced sodium mined from mines which cost $500 per ton, with sodium recycled from glass and chemical plants, costing $150. Furthermore, it implemented a low-temperature chemical extraction process using only 15 kilowatt per ton, compared to 50 kilowatt previously, reducing costs by 70%. This means a 75 kilowatt pack will cost just $1,200, compared to $1,400 for lithium. And Tesla expects to pass these savings directly to consumers. As for energy density, many were skeptical about sodium batteries because of their low energy density, 120-160 Wh. But with stacking technology similar to that of aluminum, sodium batteries can reach 275 Wh, surpassing BYD's renowned Blade battery, 165 Wh. They're also extremely durable, up to 15,000 charge cycles, and maintaining 90% capacity at 30 degrees, well above the 60% of lithium. Tesla's future promises to be revolutionary: faster, cheaper, and safer batteries that could forever change the way we think about electric cars and energy. With sodium battery costs at an all-time low, Tesla is putting enormous pressure on BYD, which relies on its cost-effective blade battery to drive sales. Now, with cheaper, better quality batteries, BYD's cost advantage alone won't be enough to compete. If you want to understand all of Tesla's new battery technologies and see how far ahead they are of the competition, I recommend checking out our in-depth videos on the channel. And where do aluminum and sodium fit into Tesla's future plan? The specifications of the aluminum and sodium batteries make it clear why Elon Musk is betting on these two technologies. The big question now is, which models will actually receive these batteries? For current models like the Model 3 and Model Y, aluminum-ion or sodium-ion are unlikely to replace LFPs in the next 2 years. Tesla's new cathode formula has just been patented and will be applied to these models in 2026 and 2027. Therefore, the focus of aluminum-sodium batteries will be on entirely new models. Sodium batteries will likely appear in the robotic van, expected in early 2027. They offer low cost, high load capacity, and stable performance in extreme temperatures, perfect for continuous operations in urban freight transport. Aluminum batteries, on the other hand, are a better fit for the Tesla Semi, offering high energy density and greater range. These technologies are expected to debut in the 2026 Model 2, with two planned versions, one with an aluminum battery for performance and extended range, and another with a sodium battery for the ultra-affordable standard model. However, launch schedules will differ due to the mass production capacity of each technology. For aluminum batteries, production tests in Q3 2025 indicate that the mass production line could be ready in 10 to 12 months. Initial production is expected to reach 80 GWh per year at the Giga Nevada and Giga Texas plants, where Tesla is expanding its dry electrode lines to integrate aluminum. Additionally, Tesla is working with redwood materials to scale aluminum recycling, reducing energy consumption by up to 95% compared to new aluminum production and cutting raw material costs by 40%, from a previously estimated $60 per kilowatt to $36 per kilowatt. This means aluminum packs for the Model 2 would cost around $2,200 to $2,400 each, allowing the car to launch for $19,000 in the third quarter of 2026, with a premium-focused performance version and an initial production run of 300,000 units. Meanwhile, the sodium battery testing phase at Giga Shanghai, in partnership with CL, shows that Tesla is ready to commercialize this technology within 4 to 6 months. Mass production will likely move to Giga Texas starting in December 2025, with a capacity of 100 GWh. The Model 2 with a sodium battery will be the base model, priced under $17,000, targeting the low-cost market in the US and Asia, with the first 500,000 vehicles expected in the second quarter of 2026. The shift to aluminum-ion and sodium-ion batteries should also significantly improve the production and delivery of Tesla vehicles. These batteries do not rely on scarce minerals, ensuring greater supply chain stability and reducing the impact of geopolitical disruptions, particularly from China. Furthermore, production costs could fall by up to 40%, and the lead time for refining and transporting materials will be significantly reduced. Combined with Tesla's chassis production line, which assembles a car frame every 5 seconds, this means the Model 2 could be delivered 4 or 5 times faster than currently. Instead of waiting 4 to 6 months like the Model Y, the order-to-delivery time could be reduced to just a few weeks. So that's it for Tesla's latest aluminum-sodium-ion battery developments. These updates show they're redefining the EV game with cheaper, safer, longer-lasting, and high-performance batteries. Now I want to hear from you. Which of these technologies excites you most? And if the affordable 2026 Model 2 actually arrives with these two batteries, would you be ready to secure yours? Like, share, and let me know in the comments if this review was helpful. Thanks for watching, and we'll see you in the next videos. In short, Tesla is about to transform the electric car market with aluminum-sodium batteries, faster, safer, cheaper, and with impressive range. These technologies not only reduce costs and production time, but also demonstrate that Tesla is light years ahead of the competition. If you want to stay up to date with every new development, analysis, and test of these innovations, subscribe to the channel now. Activate the bell and join our community of enthusiasts who closely follow everything happening in the world of Tesla and EVs. You won't want to miss what's next. For years, China dominated virtually the entire global battery supply chain. It was there that lithium became a powerful geoeconomic weapon, with around 95% of global LFP battery production and over 90% of the refining process for this metal concentrated in Chinese hands. Every new electric car produced in the West bore invisibly Beijing's signature. But something is starting to change, and the person responsible for this turnaround is Elon Musk. With his unpredictable ways, he seems to have found a loophole in this empire, a brilliant, lightweight, recyclable alternative that's 30 times more abundant than lithium: aluminum. This isn't a new metal. It's already present in airplanes, satellites, power cables, and the cans we use every day. But now aluminum takes on a different role, that of a protagonist in a true energy revolution. The big difference lies in abundance. While lithium depends on a few countries and environmentally aggressive extraction processes, aluminum is virtually everywhere, including in the United States. Today, there are over 700 million tons available, compared to only 22 million tons of lithium. This disparity completely changes the game and redefines who sets the rules. By replacing lithium with aluminum, Tesla isn't just seeking a technical solution. Its goal is to strike at the heart of Chinese dominance and, more than that, pave the way for unprecedented industrial and geopolitical independence. The idea is simple and powerful. Use a metal that can be mined locally, with less environmental impact, and at a much lower cost. Furthermore, by eliminating the need for cobalt and nickel, two elements also controlled by Chinese companies, Tesla is quietly beginning to dismantle the tripod that supported China's empire, like slowly removing the legs from a chair without anyone noticing. And the most fascinating thing is that this revolution isn't happening in some secret laboratory, but inside the Tesla Model 2, the company's most daring project to date. A car that promises to cost less than $20,000, but with enough technology to last decades. To make this possible, Tesla needed a battery that was cheap, efficient, and independent of political or logistical pressures. That's where aluminum comes in. Lightweight, affordable, recyclable, and widely available. Everything lithium never could. But the choice of this metal goes beyond engineering. It carries symbolic and strategic significance. It's as if Elon Musk is telling the world, without saying a word, that he no longer intends to depend on a supply chain vulnerable to trade wars, pandemics, or the arbitrary decisions of a superpower. Instead of going with the flow, Tesla decided to chart its own course. And this changes the course of everyone watching: automakers, governments, suppliers, who will need to rethink their strategies. This transformation impacts the entire production chain, from extraction to refining, from transportation to assembly. Each step becomes simpler, cheaper, and more sustainable. Battery manufacturing costs alone could fall by up to 52% with the use of aluminum, a figure capable of scaring competitors and delighting investors. On a global scale, this translates into billions of dollars in savings. The environmental benefits are also enormous, especially pleasing European regulators, who are increasingly focused on sustainability. What seemed like a mere technical decision is gradually revealing itself to be a sophisticated geopolitical move. Interestingly, China, which built its dominance on scarce resources and expensive processes, may find itself cornered without firing a single shot. With aluminum, Tesla has chosen a lighter, cleaner, and freer path, a choice that threatens not only the profits of Chinese companies, but the entire logic of the battery market. This shift marks the beginning of a new technological era and triggers a silent alarm in Beijing. For the first time in decades, the West's energy future can be decided without relying on Chinese mines, refineries, or subsidies. With a single metal, Tesla is tearing down a castle that took years to build. And the whole world watches, this time, not as hostages but as protagonists. If aluminum symbolizes freedom, efficiency is the driving force behind this historic transformation. Aluminum-ion batteries don't just represent a material change, they represent a complete revolution in electric vehicle performance. The first major impact is on charging time. While lithium-ion batteries still require 30 to 40 minutes at superchargers to reach 80%, The new aluminum-based model reaches a full charge in less than 10 minutes. This completely changes the user experience and eliminates one of the biggest psychological barriers that still keeps many people away from electric cars. The secret to this speed lies in the battery's internal structure. Unlike lithium, which carries only one electron per ion, aluminum carries 3. It may seem like a technical detail, but in practice it means something enormous. A much more intense movement of energy within the cell. It's like comparing an eyedropper to a faucet turned on full blast. What these aluminum batteries enable today seemed like pure science fiction until recently. Fully recharging a car in the same time it takes to make a cup of coffee, without overheating, without risking fire, and without compromising battery integrity. Let's face it, that in itself would be an incredible feat. And it doesn't stop there. While lithium batteries degrade over time, losing capacity after a few years of use, aluminum proves to be a true marathon runner. In laboratory tests, these new batteries withstood more than 15,000 recharge cycles, maintaining more than 90% of their original capacity. In practice, this means a car capable of driving over 1 million kilometers without needing a battery change. It's not just durability, it's longevity in its purest form. And safety also makes an impressive leap forward. As advanced as they are, lithium batteries still face the risk of thermal runaway, a phenomenon responsible for spontaneous fires in some cases. Aluminum batteries, on the other hand, are naturally stable, even at extreme temperatures, from 50 degrees C to 150 degrees C, without any risk of explosion. It's a change that completely transforms consumer confidence. Imagine being in a closed garage, underground parking lot, or secluded road and knowing the risk is virtually zero. It's a relief, especially for those with families, children, pets, or simply who want to sleep soundly knowing their car is safe. Another crucial point is weight. Aluminum-ion batteries are about 65% lighter than lithium-ion batteries. This may seem like a technical detail, but it directly impacts vehicle performance. Less weight means faster acceleration, lower energy consumption per kilometer, and less wear on tires and suspension. In short, greater efficiency with less effort, and as a bonus, a much smaller environmental footprint. Now imagine combining all this: lightness, ultra-fast charging, and thermal resistance. The result is an electric car that drives like a sports car, consumes energy like an electric bike, and requires so little maintenance that it's close to a household appliance. Plug it in, use it, recharge it, and it's ready to go. It sounds simple, but it's precisely this simplicity that can win over even the most skeptical consumers. Tesla understands this perfectly and is investing heavily in this new technology package. But perhaps the most transformative aspect is recyclability. Unlike lithium, which requires expensive and polluting processes to be reused, aluminum can be recycled infinitely without losing performance. It's estimated that 95% of the material can be reused, paving the way for a truly circular economy, where old batteries can be reused at low cost and with minimal environmental impact.